Good morning, everyone. My name's Ronnie McKenzie. I am a water loss specialist. I have been working with the International Water Association for the past 25 years or so on water loss management. I chaired the group a couple of times, and we had a couple of conferences down here in Cape Town in South Africa. And Peter has asked me just to give a bit of an overview today on leakage, which hopefully we'll come on to in a minute. And basically it's an overview. I'm going to give you a bit of background on the BABE, Burston Background Estimate methodology. I'm also going to talk a little bit about pressure management, night flow analysis, leak detection, logging and the analysis of night flows, and the dangers of intermittent water supply. So I'm going to cover these items fairly quickly. I think we've got about 45 minutes and then a few questions. So hopefully you'll find it of some interest. And basically I've been in the water sector for about 35 to 40 years. I try not to think about it too much. My background, I'm a civil engineer. I specialized in water resource planning and developed some of the models that are used by South Africa to manage the water resources, moving water backwards and forwards from different countries and different parts of the country, and then moved into the water loss management. So my background is civil engineering, and that's it. So here we go. I normally show this slide just as a kind of starter. I'd like you just to have a quick look at this. This is a logging result. It's a graph of water going into an area. It's a discrete area. It's a residential area. And this logging result shows the water going into the area over a 3-day period. So you can see quite clearly it's got 3 peaks, and you can see the morning peak is quite a bit higher than the evening peak, and then it's got a bit of a night flow at night time. If you were to look at that logging result, would you say it's got a problem? Is this a good one or a bad one? Has it got a problem? Has it not got a problem? Would you send people into this area with leak detection equipment, or would you leave it alone? Have a think about it just for a second. I don't want you to reply to me on the chat at the moment, but just make a note, yes or no. Just write down a yes or no on a bit of paper, and we'll come on to it again at the end of the presentation. Okay. Now, when we talk about leakage, and I'm going to take you through things fairly quickly, but just to give you the general theory of leakage and what leakage is all about and how we manage it, we're going to concentrate today, this morning, on physical leakage, which is often referred to as real losses. The commercial losses, which are often called apparent losses, I'm not going to touch on that this morning. We're going to talk about the real leakage, the real losses. Now, when you look at leakage, it's important to try and differentiate between the different types of leakage that you get in a system. And that is where the BABE methodology was developed originally by the UK water industry when it first privatized back in the late 80s, early 1990s. They created a methodology called the burst and background estimate methodology, which effectively, it's not rocket science, it's actually very simple. It effectively means that you look at the different types of leaks in the system. Burst leakage is your large leaks, which are typically, most of them are on the connection pipe and some of them are on the water mains. So it's big leaks, generally quite obvious leaks. They are called bursts, or in America, they call them breaks. But anyway, we'll call them bursts today since it's based on the UK water industry. Other than that, your system will always have small leaks, which can often, you can have hundreds, thousands, many of these small leaks, which are called background leaks. So you've got the big leaks, which are the burst leaks, and you've got the small leaks, which are background leaks. The big leaks, it's cost effective to go and look for them and repair them. The small leaks, the background leaks, it is not cost effective to go looking for them. In some systems, the main problem is burst leakage, and in other systems, the main problem is background leakage. It's important that you try and figure out which one is your biggest problem, because if it's background leakage, you're wasting your money sending people in to look for the leaks because they won't find them. And if it's burst leakage, then you can send people in. The third type of leak, which is internal household leakage, that varies from system to system. A lot depends on what level of payment you've got for the water. If everybody's paying for their water, you typically find the household leakage is actually quite low. In areas where people do not pay for the water, you often find the internal household leakage is very high. So it's important to figure out which it is. You can often detect whether it's internal household leakage by monitoring the sewer flows at night time. So that's one of the ways that you can figure out where the leaks are. If it's burst leakage, you'll see it on the roads and maybe in the stormwater systems. Background leakage, you typically don't see at all. And internal household leakage, you'll pick up in the sewer systems if you have waterborne sewage. Okay, so we've covered BABE. That was the UK water industry. They developed a whole bunch of different approaches to managing leakage. There's a little background leak there, just to show you a background leak. It's tiny. It's not worth looking for. You won't find it with leak detection equipment, but they are there in your system all the time. You cannot get rid of them. The only way to reduce background leakage is either reduce the pressure or rip out your network and replace your network. And even then, you will always have some level of background leakage. You can't get rid of it at all. Burst leakage is normally quite obvious. Not always, but generally quite obvious. This is a burst water main running at about 20 cubes an hour at about 50 meters of pressure. This is a connection burst. Again, most burst leaks are actually on the connection. That is the weakest part of the network. And most of the leaks do occur on the connection between the main and the water meter. Now, in the UK water industry decided that if you're looking at physical leakage, then the BABE methodology is geared to help you manage physical leakage. And one of the things we look at is logging and the analysis of minimum night flows, which I'll come on to in a minute. Another item is the water auditing. We have a standard water balance, the IWA water balance, which is available off the internet, or many of us will be happy to help you with that if you need details on that. Economics of active leakage control. That is how often you should send teams in to look for leaks in areas where you think you have a leakage problem, but you don't know where the leaks are because they're not visible. So you send a team in with leak detection equipment, looking for leaks, and the idea being that if they find them, you should fix them. We'll come on to this a little bit later, but the main message here is don't send people in to look for leaks if you're not already fixing the ones you know about. That is generally a rule of thumb. Pressure management is one of the key elements of the BABE methodology, and we're going to talk about that this morning together with the logging. So we'll talk about pressure management to start with. Basically, pressure management in many cases is the low-hanging fruit. It is often an intervention that you can implement quickly and effectively, and it will make significant savings, big savings. It will often give you paybacks of less than a year and occasionally down to 3 or 4 weeks if you implement it properly in areas of high leakage. The other message with pressure management is if the underlying problem in your system is high water pressure, then if you just fix the leaks and you don't deal with the high water pressure, then you're wasting your time and money, because the leaks that you fix will just pop somewhere else and the system will hit a balance at a certain pressure. So if you're going to implement leak detection, it's often a good idea to bring pressure management in at the same time. And as you fix the leaks, you gradually lower the system pressure at the same time. Okay, this is just a picture of a leak at low pressure, and this is a picture of the same leak at high pressure. So pressure drives leakage. Most systems are designed to give a set minimum pressure at a critical point during periods of peak demand. Okay, so typically at peak demand, your pressure at the critical point somewhere in the system might be 20 meters. That is normally dictated by the fire department. They generally want a minimum pressure of around 20 meters in order to supply enough water in the event of a fire. Now at night time, that pressure builds up. So at night time, you've got high pressure in your system. And the idea being, a lot of pressure management is that during the daytime, the pressure's normally quite a bit lower than at night time. And at night time, as the system starts replenishing and the reservoirs start filling up, the static pressure in your system increases. And that is why most of your burst pipes will occur during the nighttime period. As I say, at nighttime, the static pressure builds up. It also means that at nighttime, your leaks are running much faster than they run during the daytime. So if you can do something to reduce the pressure at nighttime, then you may make big savings. It's not always the case. Sometimes you don't have pressure. Sometimes you're on intermittent supply, in which case it's a different problem. Here in South Africa, we've probably pioneered some of the largest advanced pressure control installations in the world. The biggest one that was built at the time was back in 2000 in a place called Khayelitsha. Khayelitsha is it's a low to medium level housing area. It's got some very dense houses. It's got many houses that have waterborne sewage, etc. So it's got a variation of housing types. 70,000 stands, 110,000 households. Average operating pressure was 60 to 80 meters, and we supplied over 500,000 people from a single installation. We put in advanced pressure control. Advanced pressure control is simply normal pressure control where we add an electronic controller or a hydraulic controller for that matter, which will reduce the pressure at nighttime or during off-peak periods when you don't have a high demand. So you're lowering the pressure when the demand is low, and in that way you reduce the leakage. And in this particular installation, this particular installation, we were saving 9 million cubic meters of water per annum, which is a fair chunk of water. It's about a megaliter an hour, or a megaliter every 2 hours, I think. Hourly savings were 1,000 cubic meters an hour. That's a megaliter an hour we saved on that installation. The payback was about 3 weeks. We built another one also in Cape Town, also a big guy. Here's a picture of it here. Big installation, also supplying 500,000 people. This one didn't save 9 or 10 million cubes a year. It saved about 3 million cubes a year. The third big installation, pressure management one that we built in South Africa, it was built as a public-private partnership where the private party paid for the installation 100%. We built it, we ran it, we operated it for 5 years, and we received 15% of the savings each year for 5 years. So we received roughly about 75% of 1 year's savings. In a public-private partnership like that, if it's a performance-based contract, you're typically looking at trying to get somewhere in the order of 1 year savings. So if you do it over 2 years, you would want 50% per annum for 2 years. Or if you do it over 4 years, you'd want 25% per annum of 1 year's savings. It all depends on the level of leakage to start with. And you have to build up your model to figure out where you pitch the level of savings. But generally, it shouldn't be more than 1 year's savings that the private party gets paid. And you should always put a cap on it to make sure that the savings are not astronomical and that you end up paying an astronomical amount of money for something that you could have got for 5% of the price. So it's a bit tricky that way. This is the installation. It's a big one. It's still running. This was built in 2005. It's still operating. It also supplied 500,000 residents, high pressures. Interestingly enough, 80% of the water went back through the sewer network. So we were flooding the sewage treatment works, and still are, in fact. I mean, the leakage is still very, very high, and the leakage was running into the sewers, and at night time the sewers were running with clean water, which is the worst thing that you can put into sewage treatment works, because the whole process of a sewage treatment works relies on getting a certain amount of goodies for the little bugs to eat and process and churn everything up. If you flood them with clean water, then they just get washed out the system. And in the morning, when all the goodies arrive, there's nothing left to eat, to gobble them up. So it's a very important thing that you don't wash through a sewage treatment works with clean water. The savings, again, in that installation, we had a minimum night flow of 2,800, which was astronomical. We built this big installation. I'm going through it quite quickly just to let you see a few of the pictures. We used everything was done by hand in order to create employment. That was part of the deal. So that big hole that you see there was dug by hand. This is us cutting into the pipe. This was us welding on the main flanges to the pipe. You have to weld on the flange. You can't just weld straight onto a pipeline. It doesn't work because most pipes, if they've been in the ground for any length of time, are slightly oval. And if you try and weld a round pipe onto an oval pipe, you're in trouble. It just doesn't work. So you weld big flange plates on, and that's what we did there. This is us bringing the installation in. We brought it in, and the results, we managed to save about 9 million cubes of water. Again, very similar to the previous one. There's the savings, a picture of the savings. And when you put it into money terms, it was quite significant. It saved about $20 million over a 5-year period at the time. Bear in mind, the water cost when this was built was 2 rand, South African rand per cubic meter. The water is now 12 South African rand per cubic meter, which is almost $1 per cubic meter. So if we were to build this installation today, the cost of the water has gone up 6-fold, and the cost of building the installation is probably doubled. So we would be 3 times more effective if we were to do this installation today. So the payback would be best part of a week, maybe. So this is quite an interesting one. Okay, back to the BABE methodology. I showed you this slide a minute ago. We're still on this one. I'm now going to look a little bit at logging. We're looking at the logging and minimum night flow analysis. Now, there's 4 BABE models. Now, I was listening to the previous discussion, so this one's a bit inappropriate, this slide, so we'll take it off quickly and we'll do something more like that. It's probably even less appropriate, but anyway, these are the 4 pioneers from the IWA of the water loss management. They're the previous chairman of the IWA water loss management. It's Bambos Charlambos, Ken Brothers, Tim Waldron, Stuart Hamilton, and I'm actually number 5, so I should be in there somewhere. But anyway, good bunch of guys. None of them are monsters or anything like that, I can assure you. They're very happy to share their knowledge with everyone. And in the IWA, we have very many lady members. And when we organised our conference in Cape Town, it was organised, I think our committee was 6 lady members and we only had 2 men. And it went really, really well, I have to say, because the men kept out of it and just let the ladies do everything. So that, it sounds a bit chauvinistic, that, but they wouldn't let me do anything. I was actually told to butt out and just let them get on with it. So anyway, we had a good conference in Cape Town. We've developed 4 BABE models, which are designed to help water utilities manage their leakage. And the models are Sandflow, Benchleak, Pressmac, and Econoleak. They are available free of charge from the South African Water Research Commission. And we've just been appointed to a 2-year contract to redo the models, make them look a bit nicer and a bit easier to use. So we'll be working on that for the next 2 years. The Sandflow model is the night flow model. And basically what we're doing is we're trying to look at a logging result. Now, I showed you one at the very beginning, and I asked you whether we had a leakage problem. Well, the Sandflow model is designed to help you analyze whether or not you have a leakage problem. And what it does, it is a full BABE, burst and background estimate model. It breaks the night flow down into 3 components: bursts, background leakage, and normal night use. Now, we can estimate the normal night use, and we can estimate the background leakage from the length of mains, pressures, all that type of thing. So you can, the bottom two blocks, you can calculate roughly, not exactly, but you'll be close enough. It doesn't actually matter too much. You'll be pretty much within reasonable levels of accuracy. Then you subtract that, you add the background leakage and the normal night use together, subtract it from your minimum night flow, and the difference is then your unexplained burst leakage, and that's what you're looking for. I'm not going to go into it in detail. The model's available. We can have a whole presentation on this, just on this. So I'll go through it fairly quickly. This is a night flow analysis. This is showing you the 3 days, a 3-day logging result with the pressure. And you can see the pressure creeps up at night time as your minimum night flow drops. Here's your minimum night flow. You can calculate the expected minimum night flow using the BABE methodology or sand flow, or you can just do it on the back of a matchbox. It's not going to make a big difference, but that is what you do. And this is then your excess night flow. You want to know how much leakage is in an area so that you can go and look in that area. Now here's a logging result. This is a 7-day logging result. And you can see that it's a domestic area. And you can see we've got a minimum night flow of 18. And we've got an average daily demand of 64. Now, you can use the BABE methodology to go to that 18 and see how much of that is expected and how much is excess. A quicker way of doing it, and it's a new performance indicator that I'm recommending that the IWA adopt, and I'm sure they will adopt it. They're just a bit slow sometimes, but they'll get there. I call it the night flow ratio. And you divide the average daily demand by, you divide the minimum night flow by the average daily demand. So you divide 18 by 64 and you get a ratio, and that ratio gives you a good estimate of whether you have a leakage problem or not. In that case, it would be what, 18 divided by 64 is going to be about 0.3, I would guess. 0.28. Okay, that wasn't a bad guess. I knew the answer anyway. A good number would be 0.1. And a kind of borderline number would be 0.2. Anything above 0.2 is a bad number. That's high leakage. So even although this logging result looks quite good, it's got 0.28 ratio, which means it's about 28%. Most of which will be leakage. So it's a very quick and easy estimate that you can use to calculate whether you've got a leakage problem. This is these are real examples from real areas that we work in. This is another example to show you what we do. Minimum night flow is 125. The average daily demand is 150. Your night flow ratio, hang on, I need to move this little window, is 0.83. That means you've got astronomically high leakage. That is really high. This is terribly high. Now, to get those logging results, you need a logger. Now, there's many different types of loggers. We use some that we import from England, but there's South African loggers, there's loggers from Europe, America, Japan, whatever, China. I would recommend you get a good one. There's no point wasting money on a logger. There's no point putting in a cheap logger when most of the effort is actually getting to the zone and then you put it in. This is a logger from the Kruger Park that sat there for 7 years. It's not quite as big as it looks in the picture. There's an elephant in the background for scale. The logger's actually only about 6 inches tall, so it's not a big thing. It's a battery-powered logger, and it transmits the information using GPRS or GSM. It's a GSM system. You can use SMS messaging or GPRS. So we use GPRS, it's cheaper. You can use solar panels on some loggers. Our loggers are battery powered. We don't like solar panels. You need to employ protection. In this case, it's protected by, I think it's a leopard there, just looking after the solar panel. Otherwise, they get stolen, as you probably know. So our loggers typically have a 5-year battery, so we like the battery ones. You connect the logger to a water meter. Again, we've got to protect the logger. We need everything. We work in areas where anything that moves will move. So we often have to lock it up in a steel box to protect it. There's one of our installations there. It's not terribly attractive. The box is not it's the design, it's functional. It's functional. You need a crowbar to take it off, and most people don't bother too much. So anyway, how much water do you lose through a leak? I think it's important just to get an idea of how much water a leak uses. I like to show this one ran for 3 hours. It lost 60 cubes. This is another one. This one ran for 6 hours, lost 240 cubes, big leaks. This is a huge leak. This is a Rand water leak. It ran at 200 cubes an hour for 3 hours. It lost 600 cubes of water. Here's a little one. You wouldn't think that would lose too much. It lost 2,000 cubes. The reason being it ran for much longer. It ran for 3 months. This one ran for 3 years and lost 13,000 cubes of water. So it's not the size that counts for a leak. That it's very important that it's the running time. It's how long it is running. That is the key element. So don't ignore the small leaks. If you know of a leak, don't let it run for a year, because you'll end up losing enormous amounts of water. Now, there's a lot of new technology on leak detection. You've heard of the satellite. There's satellites now that apparently can look down and spot a leak from outer space. Elon Musk has put up about 400 satellites, and there's all sorts of companies offering you a service. You can sit in your office and do nothing, and it will find the leaks for you and tell you where they are. Supposedly, our success rate with the satellite leakage, our clients that have used it have been less than impressed, I would say. There's new technology. There's dogs now that can go and sniff leaks out. There's a dog, it's an English something or other. This is I call it a large canine leak detector. We like acronyms, so it's an LCLD for short. They can apparently sniff out the chlorine in the water. The trouble is, after a few days, the chlorine's gone anyway, and you won't be able to sniff it out. So I'm not sure if it works. We tried it in South Africa. It didn't work. We used I think it's a big Ridgeback and a little sort of Italian greyhound. We thought we'd found a leak at one point, but it was a false. It was a bone, I think. It didn't work. Again, looking for leaks, don't waste time if they're obvious. I mean, fix the obvious first. That's the cheapest water you'll get. So if you've got this type of thing and you've got leakage, before you spend money on a satellite or a dog's actually maybe worthwhile because they're very loyal and they can be friends. So, I mean, at least if you buy a dog, you get something for your money. On the satellite, I would wait until you've fixed all your leaks before you buy a satellite or hire a satellite. Fix the ones you know about. That's my word of advice to you. Finding, I would say that logging, continuous monitoring is becoming very cost effective. You can monitor all sorts of things: water quality, chlorine, pressure, flow, level within a reservoir, level within a borehole, all sorts of stuff. It's now becoming very cost effective to monitor it continually. And that information is very, very valuable. We have our own, we've got our own web-based system with about 10,000 loggers reporting every morning. You can use any sort of logger. It doesn't have, we use GPRS loggers, we use Sigfox loggers, we use radio frequency loggers, we use LoRa, low range or something like that. I've lost track of all the acronyms, but basically they all grab the information and send it into the cloud. We grab it in the cloud and then we display it in a database that helps you analyze what's going on. So we run our own system. There's lots of systems available. Every country will have someone with their own system. So we like ours. We think ours is the best in the world, but so does everyone else. They all think theirs is the best. So some logging results, just to show you what we get when we do logging. This is a good logging result. This is what you'd look for. This is an office complex over 4 weeks. You can see that you've got Monday to Friday, you've got a nice demand, which is people working in the office. And then Saturday and Sunday, we don't work Saturday and Sunday at the office. We go and play golf and talk business with our friends. I don't play golf actually, so I do other things. I'm like Peter, we do cycling on our own and don't talk to anyone over the weekend. So we're kind of cycling hermits. Anyway, you can see the weekends have got no demand there. And you can also see on week 3, there's only 4 peaks. Why is that? Why don't we have a 5th peak? It was a holiday, that's why. We had 3 days, so we don't work on holidays either. So you can see this is what you're looking for on a nice logging result for an office. There's a Saturday and Sunday, there's your holiday, and you've got the key thing on leakage. Look at the night flow. You've got a minimum night flow of almost 0 here. This is another month, another 4 weeks. What happened here? Doesn't look quite the same. It's not as nice. Things are happening here. What's happening? Interestingly, you look at the minimum night flow. You see that the minimum night flow, now there's a holiday by the way, we've got a toilet cistern leaking. We decided that in order to save water, we would put in dual flush toilets. We thought that's a good idea. Everyone in America does that, in Australia, and they save lots of water. We'll do the same here in Pretoria. Didn't work. Our water's got silt in it, or dirt or something in it, and it blocks up the valve and the toilet cistern starts sticking. So after spending money on expensive European dual flush toilets, we eventually had to take them out because we were wasting more water than ever. So the dual flush toilet thing didn't work for us. I'm not saying it won't work for you. You might be in a place where you've got high quality, the water quality doesn't have any dirt in it or silt or something. But this is another one. This is our office, the same office. You can see a leak developed and it just grew. And we should have fixed it within the first week. Our system kept sending us alarms every morning. I would get an alarm on my phone to tell me, I think you've got a leak. You might want to do something about it. Because it's a body corporate, I decided I'll phone them. I'll tell them they've got a leak. I'll let them deal with it, see how that works out. After 6 weeks, I couldn't put up with the phone calls any longer. And I went out and I found it and I fixed it. The body corporate were still messing about, trying to get 3 quotes from plumbers and then get all the owners to agree to do something about it. As I say, eventually I just couldn't take it any longer. So we went and fixed it ourselves. That's the leak starting. That's the leak repair. That's the volume of leakage that we lost. And that was our toilet cistern still leaking. We still had it at that point. We've got rid of it now. We took them out and replaced it with a normal standard toilet. This was our office complex for the first 10 weeks of logging. When we started logging our office complex, we didn't think we had a problem. We didn't know we had a problem. We actually thought everything was fine, but as soon as we looked at the logging, we saw, wait a minute, we've got some leakage here. And we spent quite a while, about 6 weeks, going round all the different offices to try and find out where the leakage is, what was causing that night flow. And eventually, we managed to get it down to virtually zero in a complex. And what's interesting, the water use in our office complex is now 20% of what it was previously. And it had been at that level for 20 years. Nobody knew what it should be. So office complexes often are quite, you might find there's savings to be made. This is another one. This is an industry, just a single factory. The reason you can see that is it's got a 5-day demand, and then the weekend demand is quite low. If it was a townhouse complex, you wouldn't have that low demand at the weekend. So the logging results are quite interesting. Leak develops, there's your leakage, that's it repaired, and it ran for about 10 days. It wasn't a big leak, it was running, it's like a tap running fully open for 10 days. There's your Monday to Friday, and there's your Saturday and Sunday. The cost of the leak, that 10-day leak, was about $2,000, just under $2,000. Without the logging result, it would probably have run for 6 months before someone figured out that they were getting a high water bill. Because a lot of the time, the councils don't read your water bill monthly. Some of them use estimated readings and then check every 6 months to see if everything's fine. So be careful about that. This is another logging result. This had been running at 25 cubes an hour for about 3 years. And we put a logger on and we found out that the meter was turning continually. And it was just a pipe that had been burst since when they put it in. And the owner of the industry was getting the same water bill every month, and they just thought it was normal. Here's another one. This is an evaporative cooler where you've got a big pan of water and you've got a fan blowing air over the water in order to get a cooling effect. You get that in quite a few hotels, airports, that type of thing. Nobody knows how much an evaporative cooler should be using, apart from the people that sell it to you. And they're not going to, they're gone long ago. Nobody knows what's going on. So whoever runs the hotel or the airport, they've got no idea how much they should be using. And in this case, the valve was running open most of the time, and the water was just spilling into an overflow into the sewer, and nobody was aware of it. By fixing a cheap valve, we managed to reduce the water consumption by, we dropped it from 54 cubes a day down to 18. So it was quite a big saving, that one. This is another one. As soon as you see a lot of blue, you know that there's a lot of leakage. So this is a particularly interesting one in that it was the pressure at night time was actually lower than the pressure during the day. It was the opposite of what it should be. I've never seen this anywhere before. And it was mainly due to the fact that the leakage was up at about 98%. So there you go, there's consumption. And it had a minimum day flow, not a minimum night flow. So it was totally bizarre. Had the pipe been bigger, the leakage, the only thing constraining the leakage was the size of the supply pipe. If we put in a bigger supply pipe, we could have doubled the leakage quite easily. So that was an interesting one. Here's another one, intermittent supply. Very bad. You don't want to have intermittent supply. This is an example, and you can see the leakage here was astronomical. And in areas of intermittent supply, you normally find that the leakage becomes very, very high. This one I'm not going to waste too much time on. This is someone's opened a boundary valve here. You can see the minimum night flow changes. We've got a bit of pressure building up during the day. There's the minimum night flow goes to 0. It can never go to 0. If it goes to 0, something else is wrong. What's happening here is we've got a pressure backup coming in from an adjacent zone, and it's closing a pressure reducing valve. So the pressure downstream of the valve is higher than the pressure upstream, and the valve closes. You get a 0 minimum night flow, which you think you've got no leakage, but you're just supplying the leakage from an adjacent zone. So the logging is quite helpful. It can tell you all sorts of things. This is another one. You can see here, this is a pressure reducing valve. The pressure reducing valve starts failing at night time, and the minimum night flow creeps up with it. This demonstrates that pressure drives leakage. As the pressure increases, the leakage increases. The valve eventually fails completely, and that was it. Now, something else, intermittent supply. I just showed you this graph. Very bad. You do not want to go on to intermittent supply if you can avoid it. When Cape Town had its day 0, they managed to reduce their demand by over 50% without resorting to intermittent supply. Intermittent supply causes your network to, you get air in the system, you get bugs, you get sucked sewage into the system, you'll get cholera, typhoid, all sorts of terrible things with intermittent supply. Do not go there if you can avoid it. It should be the measure of last resort. Okay, what you want to do, and you can do it, you can move on to a continuous supply at a lower pressure. If you lower the pressure, you may be able to supply the area with full supply, but at a lower pressure, and you can end up dropping the average daily demand. So by giving a continuous supply at a low pressure, you may end up supplying less water than an intermittent supply at high pressure. And we can talk about this for an hour on its own. Anyway, try not to go on to intermittent supply. I know it's not always possible. Often you end up in a crisis situation that you can't do anything else. But if you can try and see the crisis coming and start reducing the consumption, try and avoid intermittent supply at all costs. It's a downward spiral. It is not something you want to move on to. So intermittent supply is the measure of last resort. Try and reduce pressure rather than intermittent supply. Take action early as you move into a drought. Implement restrictions. Reduce pressure. Do whatever you can. Do not cut people off if you can avoid it. So take action early, reduce wastage, and try not to go on to intermittent supply. Okay, it's the slide we started with. Do we have a leakage problem? Well, if you look at that result, the minimum night flow is 80. The average daily demand is 150. If you divide 80 by 150, you get 0.53, which is our night flow ratio. And I indicated anything above 0.2 is a problem. So 0.53 is certainly a problem. So we do have a leakage problem. So all of those that wrote yes on the paper at the beginning, then you can take a bow. Those that wrote no, sorry, you were wrong. Thanks a lot. Okay, that's me finished. Questions, Peter?
Ronnie, thanks so much for that presentation. You are going to get a lot of questions here. You're going to get a lot from GWCL. This is a hot topic for them right now. I don't think they've seen one of your presentations before. Others have. Ronnie, I want to kick this off with a question for you. Yesterday, we had presentations by our utility partners, and we saw non-revenue water, in some cases, from 50% nearing 70%. Obviously, that's about the worst that we see. The question I have for you, Ronnie, is put yourself in the position of a utility manager. Maybe you're a utility manager in Zimbabwe. That's your new job. And you've got limited human resources, and you've got extremely limited cash resources, okay? And your non-revenue water is over 50%. So remember, your human capacity is limited and your cash capacity is limited. If I ask you to bring your non-revenue water down from 50% to say 40% in a year, can you tell me what you would do? Because what you would do as a utility manager, I'm sure those on this call will think about to say, hey, yeah, I can do that as well. So Ronnie, with those constraints, what would you do?
It's every zone has different problems. So you can never apply the same approach to every single zone. However, there are certain problems that are common to most areas. If you're up at 70% non-revenue water or even 50%, typically that's going to be a combination of both physical losses as well as metering errors and commercial losses. I would always, one of the things I would do is I'd make sure that all my top 100 customers, I'd make sure that the meters to my top 100 customers are all accurate, because that is where you get most of your money. So make sure that the meter, your top 100 customers are being metered accurately, and that gives you your income. The other thing that I would recommend is fix any visible leaks that you can, because that will always be cost effective. Once you're hitting your top customer, or not hitting them, but you're giving them a bill and they're paying for it. If your top customers are paying for the water, at least you've got some income coming in. Then you start going to the top 1,000, and then you start going to the affluent areas where people have bigger houses and they're willing to pay for the water, and you start making sure that those that can pay will pay. To try and squeeze money out of people that have no money but have high leakage is never going to work, because people just can't afford to pay for the water bills in the low income areas. So in those areas, the best thing you can do is to try and find out where the leakage is. Is it burst leakage? Is it internal household leakage? And in many cases, you might even save a lot of water by sending teams in just to put new washers and taps and all of this type of thing, free of charge to the consumers. Because a lot of people who have no money have astronomical water use. And it's often because they can't afford to replace a washer or can't afford to replace a leaking tap or something. So It's horses for courses. I really can't give you a general answer, but definitely get the guys that can afford to pay, make sure they pay, fix visible leaks as a priority, and repair all reported leaks should be repaired within 24 hours. That should be your target. Most big cities don't get anywhere near that. And once you're on intermittent supply, it's a vicious cycle downwards, because you get air into the system. As soon as you pressurize it, the air creates more bursts, and you end up with those. Some of these logging results that I showed you are in areas where we've got intermittent supply. If it's intermittent supply, you're going to be looking at 70–80% losses. It is what it is.
So, Ronnie, that all makes perfect sense, and I'm sure that it makes sense to a lot of people on the call. The second question, or the part B of the question, is this. Ronnie, you're aware that we started up this ACORN initiative to help utilities get access to capital finance.
Yes.
For them to get access to capital finance, they have to show good performance. They have to get a good credit rating, and then all of a sudden money starts to flow in. One of the issues that any of the credit agencies or donors are going to look at is non-revenue water. Okay, and if the non-revenue water is out of control and it's not lowering itself, their ability to get finance is very low. So Ronnie, you talked about the low-hanging fruit right now. Let's say you're the utility manager, your non-revenue water is 50%, but heck, you've got to get it down to 25% and quickly. Otherwise, you're not going to be able to borrow any money. No one's going to be interested in your water utility. If you've got to more dramatically bring down the non-revenue water, what would you do if you were a manager?
I'd slash the pressure.
Yeah.
I'd absolutely slash it. I'd bring the pressure down to 5 meters at night, and people then just get a trickle of water. It just keeps the pipes pressurized enough that you don't get air into. You want to avoid getting air into your system at all costs. As soon as you get air into your system, then you've got to get rid of it somehow. And the air, if you don't have air valves that are working in your system, the only way the air can get out of your system is to blow your pipeline. And then you end up having burst pipes everywhere. So Cape Town, during its day zero, they managed to get some of their biggest savings by reducing the water pressure way below their minimum requirement. The fire department, they want 20 meters of pressure. That's, if you speak to the fire department, that's what they want. There's no negotiation. The point is, if the alternative is to go on to 8 hours supply or 4 hours supply, then half the time they're not getting any pressure. So the fire department can't tell you, no, we don't want 5 meters of pressure or 10 meters. We want 20. You're only going to give it to them 4 hours a day. So rather give them 5 meters of pressure for 24 hours than give them 50 meters of pressure for 4 hours. That would be my suggestion. Pressure management is in areas of extremely high leakage. I would guess that most areas have pressure reducing valves in them somewhere. One of the most cost-effective things you can do is get your pressure reducing valves working again, because most municipalities haven't serviced their PRVs since they've been put in the ground, and half the time they've been vandalized, or they're leaking, or they're not working, or they're stuck, or there's got bricks in them or rocks. They just do. So fixing your PRVs, your pressure reducing valves, that is a highly cost-effective measure that you can do, and you can use pressure to drive down the leakage and the demand until you can get on top of the leakage, and then you can start working. I don't have the answer. Every system will be slightly different, but pressure management, fixing visible leaks, billing your top consumers accurately, all of these things will be highly cost effective to a water utility.
Would you consider, remember you don't have a big budget, would you consider a performance-based contract where the contractor is basically being paid from the savings? Would you consider that?
Bear in mind, any contractor that's going to offer you a performance-based contract, if the fee that they would get normally is $1 million, they're going to be trying to get $2 million out of you on a performance-based contract. They're going to want double what they would get paid normally to take the risk on the finance. So you need to bear in mind, performance-based contracts are an option if you've got no money and you want the private sector to come in and help you. Bear in mind, the private sector is profit driven. They're not doing it for nothing. They do it because they're going to make double the money that they would make on a normal contract. So you need to be very careful with performance-based contracts. You can end up being badly beaten up on them. And it can work both ways. I mean, the contractor, the service provider, if the client doesn't pay your bills or doesn't pay you on the savings, you've spent all your money putting in the equipment. You can't get your money back. So it's a double-edged sword in that the client, the water utility, can be badly beaten up if they don't negotiate a good contract and they don't put in a cap. They should put in a cap to protect them. But on the service provider's side, if the contractor doesn't pay your bills, or they start trying to extort money from you, or they want money to give to their brother-in-law or some, you can end up with all sorts of horrible things happening. So if you have an honest client and you have an honest service provider, and you have you know what you're doing, it can be a very cost-effective way of doing it, and it can definitely work. But it's not easy, it's not straightforward, and it requires an independent auditor to overview both parties to make sure that everything is above board and that everybody is doing their job and that the savings are being achieved and all sorts. So it's an option. It can work. Performance-based contracts are very popular at the moment because most municipalities are bankrupt. If they've got 70% leakage, they're almost certainly bankrupt. You can't run a water utility, and it's like running a petrol station and you're giving away 70% of your petrol. You're not going to last very long. So I agree. Yep, performance-based contracts can work, but have to be done properly and have to be supervised, and you need an independent auditor and you need a cap on the savings. That would be my advice.
Okay, thanks, Ronnie. All right, I'm going to shut up here and see if there are any questions from the audience.
Yep. Stunned silence.
No, you're going to get some questions. Go ahead, Joy, if you can unmute yourself.
Thanks, Ronnie, for the presentation. It's a comment from me where I just wanted to concur with Ronnie that, you know what, in the last project I did in Tanzania, you find that they were saying that the towns, the other residential areas were not getting water. So how they were going to curb that was we actually came up with more reservoirs and a new treatment plant, you know, things like that. But there were so many leaks throughout the network in the town. which for me would be the first point of call, like what Ronnie said, to say, fix that first and see if still there's no water in the areas where there was a water shortage. And then still, if you're going to connect the old system to the new system where you have a new treatment plant and new reservoirs, then still you're just going to increase the pressure for leakage. So I think as local authorities really need to be trained, or really need to be refocused to say, for you to get other areas that don't get water now, getting water doesn't mean just getting more water into the system, but it actually means you need to fix whatever leaks are there. You might find you don't even need another water source, but the water there is adequate for everyone if only you could fix the existing leaks. So that was just what I wanted to comment. Thanks.
I totally agree with you, Joy. If you've got 70% leakage or 50% leakage, you've got an enormous resource without having to build a new dam or a new treatment works. Your leakage is by far your next cheapest water source. You should consider the leakage as a resource that you can go for, and it will be much cheaper to try and grab that leakage somehow. You just need to figure out where it is and where it's going and how best to get it. But it will be much cheaper. It's exactly what you said. It will be much cheaper than putting in new pipes. And the problem is most of the big funding agencies, they like funding things like dams and new pipelines and a new treatment works. It's something they can see what they're getting for their money. They're not so keen on funding leak detection and pressure management because it's all underground. Nobody really sees what they're getting for the money. But if you measure the minimum night flows and you can show them that you're making real progress by driving down that minimum night flow, that is the key to showing these funding agents that you're actually doing something. So I agree with you completely. Your leakage is your resource that you should go for.
Ronnie, you've got I knew that you were going to get a question from Jonathan Kampada of Lusaka Water and Sewerage. They're being bedeviled by their non-revenue water. So Jonathan, go ahead and pose your question to Ronnie.
Thanks, Ronnie, for that interesting presentation, and definitely some tips which we've taken away from your presentation. But I think my question is, what's your experience on the aspect of customer metering? Why I'm saying this is that for us, we've done some assessment, and one of the areas where we've zeroed down to be a problem is on the commercial losses, and particularly on the inadequacy in the metering we have for customers. So we are trying to focus our energies now to get us 20% metering. We believe that this will drastically reduce our non-revenue water. Of course, not forgetting the other strategies that also have to be applied. Because we've got about 35% admitted customers. And just this week, for example, in our inspections, we found a property which is on a fixed charge. And in that same yard, they've connected that same connection to 4 other properties. So which means that we are charging fixed charge for 1 property, but they are connected to 4. So which means that they're using 4 times the amount of water. So we feel that if we really ramp up the metering, this would be one of our quick wins. Thank you.
Okay, I agree with you. Customer metering is a very important thing. I would caution against going to the expensive smart metering. That a lot of companies, particularly European companies, seem to think that Africa requires smart metering in order to survive. And if you actually look in Europe, the companies that are selling those smart meters aren't actually using them in their own countries. They use normal meters. I would recommend that you use a high quality mechanical meter for your customers, which is generally in the order, in dollar terms, it's probably about $40, I would guess, as opposed to a smart meter, which will typically be 200. How many dollars would that be? About, yeah, it'd probably be about $200 for a smart meter. The problem with the smart meters is that if your consumption is quite low and people don't have a lot of money, you're never going to get back the investment you spend on the smart meters. In fact, you'll rarely get back enough money just to maintain them. So if you go for customer meters, I would go for a standard, good quality mechanical meter, and there's a lot of them around. There's the Xylem one, Census, there's the Kent ones, there's a whole bunch from Europe, Grundfos. A good quality one, preferably one that doesn't have scrap value so that they don't get stolen and sold for their brass content. And I would then, I would definitely, I agree, customer metering is a good way of getting some money. In South Africa, it doesn't work that well because we've got a minimum, there's a free basic water of about 6 kiloliters a month, below which customers don't pay for the water. So if you're a normal household without leakage will only use 5 cubic meters a month if you're not using it for irrigation. And as soon as people are paying for water, they don't use it for irrigation. So as soon as you put in your meters, you're going to find the consumption drops enormously once people start paying based on the actual reading. So I would go mechanical, low cost, good quality mechanical meters. I'd employ a bunch of people to go and read the meters every month. It creates employment. It also helps pick up leakage if they're checking it every month. So definitely customer metering, I would say, is in South Africa, it's a given. It's generally 100% of the connections are metered. So South Africa is very advanced on metering, customer metering. The UK is not, funnily enough. In the UK, probably half the population don't have a meter. So they get paid based on a flat rate, which is a bad thing to do. You should have a rising block tariff on your water consumption. So don't bill on a flat rate. A flat rate creates leakage. It creates problems for you. You're losing lots of money. Thanks.
Thanks, Ronnie. Ronnie, we've got a question from.
Thank you.
Ronnie, we've got a question from GWCL in Ghana. Clifford, go ahead if you can unmute yourself.
Thank you very much. Good morning.
Morning.
Ronnie, thank you very much for your presentation. We've gotten a lot of insights into what it takes to deal with non-revenue. Let me just create a scenario for you and then to get your thoughts on it and see how you would have handled it in the situation. You have a very old water supply system. You have weak pipelines, and for that matter, the water is leaking almost everywhere. The demand has outstripped supply. And so you cannot give everybody 24/7. And so the intermittent supply that you are talking about, there is no way you can avoid it. So you will have to block the areas and give them as and when is due for you to supply. Some of these places are so far apart from the main booster stations. And so low pressures might not yield the necessary results, or the people further the area might not get water. In your experiences, such a situation created for you, how will you handle the situation to make sure that you are able to reduce the non-revenue to a level that is acceptable? And the other thing is that resources that you have is limited. And so you cannot just go repairing everywhere. You cannot just go changing things as if the resources are limited. In your experience, what do you think you would do in such a situation?
Yeah, you've definitely got the worst case scenario there. You can't really paint much worse than that. You've got really high leakage, you've got intermittent supply, and you've got a crumbling pipe network which can't handle pressure. It's probably asbestos cement pipes which have seen their best day. There is no quick fix for what you've got. There isn't really, there is no silver bullet for what you've got there. The only way you can get yourself out of that is to gradually replace the network. If your network has been experiencing intermittent supply for many years, which it sounds as though it has, your network cannot handle the pressure anymore. It's just that it's so poor that you can barely pressurize it. What I would do, I would try and get funding from a development agency, and I would start putting in a new network in areas where you know that you can get payment for the water, and start supplying 24/7 to the areas that will pay for the water. And it's going to be a 20-year program that you go for. You're not going to fix it overnight. Go for the areas where people will pay for water. The areas where people are not paying and where the leakage is astronomical. Once you're on intermittent supply, it is really difficult to come off it. It's almost you're going down a spiral that just ends up a dead end. Once you've got to that stage, it is very, very difficult to move off intermittent supply. So the only way you're going to get round this is to start ring fencing one area and trying to get on to continuous supply, and aim for areas where people will pay for the water, and at least try and get an income that you can start getting some money in, that you can then start replacing bits of network. But ultimately, you're going to have to replace your network at some point, and that is astronomically expensive. So you're in a catch-22. You need to replace your network, but you haven't got the money. So you may have to look for a private partner to come in and offer to run your network for you, and let them put in a new network and just bite the bullet. Just let them make money from you. I mean, you actually haven't got much to lose there. So it may be, you're going to need help from someone. It's the worst case scenario. Sorry, I can't give you any other answer. I can't give you a silver bullet here. There isn't one.
Ronnie, thanks. Clifford, do you have any follow-up questions for Ronnie on that?
That's fine. It's just a difficult situation, and he's agreed that this is something that can take a very long time. And I think you also need to get your staff with you as far as that effort is really concerned. Because sometimes you are at one point dealing with it, and some other staff at the other points trying to make it worse because they don't understand what you really want to achieve. It's a difficult situation. And as for the intermittent supply, in some cases, it's just too difficult. Even if you know some areas are ready to pay, giving them 24/7 it's just going to be almost impossibility. And so it has to take a very long time to be able to get to levels that you will have to. Anyway, thank you very much. Thank you very much.
Sorry, I can't give you a better answer. You've got a problem. I wouldn't want your problem. Sorry about that, Clifford.
Ronnie, can you talk about you mentioned support from development partners, development financial institutions, for example. You're aware of the interests of the Africa Development Bank and the World Bank and EIB and so on. What is their appetite to provide support to a large utility like GWCL? And if you have any idea in terms of the rates that they would charge, I mean, would these be pure loans? Would these be blended loans? What is their interest these days? I have my own opinion on it, but I'm wondering, based on your expertise, what you're seeing with the development partners.
Thanks, Peter. I think probably you've got more background to that than I have, Peter. I think your experience with the funding agencies is better than my own. I do know that in many cases, the development banks are very keen to fund new reticulation networks. So if you can find an area that you know that you can get paid for the water, and you can set up a proper business plan that shows you can put in a network and within 2 or 3 years you're getting money in, generally they will blend some grant funding, the EIB, the World Bank, the African Development Bank. They will sometimes blend some donor funding in to the funding mechanism to bring the average rate right down, and it can be cheap money. So you sometimes can get some cheap money, but they will want to see results. They want, I mean, they will want you've got to be able to ring fence an area and you generally start on the outside and sort of work your way towards the center of a large urban area. You know, the CBD, the Central Business District, is generally the last bit of the puzzle that you work in. So you normally sectorize from the outside, moving inwards. But funding, Peter, maybe you want to talk a bit about that yourself. I think you've got some good experience on that one.
All right, thanks, Ronnie. So Clifford and Jonathan and some of the other managers on this call, Ronnie is correct. The development partners have the money. They have the money. And what's important for them is, as Ronnie said, is results, but they also look at the economics, and they will work with you on the economics. So in other words, if a pure loan does not work for you economically, Clifford, in other words, your payback is 20, 30 years, they would probably be willing to work with you to find blended finance to reduce the cost of the loan. I doubt that you would be, because as Ronnie said, Clifford, there's money to be made in reducing non-revenue water. There is money to be made. I doubt that any of them would be offering you or Lusaka Water and Sewerage or Lilongwe Water Board or even Wasco and Lesotho. I doubt that anyone would be offering you a grant, but they probably would be offering you blended finance and would work with you to make sure that when you did the blended finance, that the economics worked out for you as well. So obviously someone's going to collect on the interest on the loan, but you're going to benefit by reducing your non-revenue water, bringing in more revenue into your operations. So I think it's a good option, meaning that you don't have to lower your non-revenue water entirely from your own revenue, from your own customers. You can also do it with the development partners. They have an interest in non-revenue water reduction. They all do. It's a big deal. And so it's a matter of working with them, negotiating with them, getting the best rate that you can get, and then looking at the overall numbers. And as Ronnie said, for a system as, and Ronnie, by the way, GWCL, we learned yesterday that they now serve 17.5 million people. Okay, so that's huge. And Clifford, Ronnie and I both know that for any of the development partners, whether it's EIB, African Development Bank, World Bank, they like those kind of numbers, and they like the kind of revenue that can be generated by GWCL, but not just you, also Lusaka Water and Sewerage, Longway Water Board, and others. So I think there's a real opportunity there because they have the money, they're interested in it, they'll help you with the math, they'll help you get other people involved so you can get some blended finance. Okay, other questions? Barring none, it's been a long morning, but Ronnie, I'm glad we ended up with you. If there's anyone to keep everyone awake, it's you towards the end. We have this recorded, so if you didn't remember everything that Ronnie said, or you wanted to review some of the graphs that he provided, you can see that later. Ronnie, I want to thank you. I think Joy, you're still there on the call. Thank you. In absentia, I'll thank Joe Parker as well, and all the excellent questions and everyone for attending. I hope you got a heck of a lot out of this. But again, Ronnie and Joy, thank you so much for sharing your time, your knowledge, your experience with all those on the call. The people on the call are serving 22 million people. More than 22 million people. So it's a big deal what you've done to provide them with assistance. I'll take one more question, then we'll wrap up. So Ronnie, we've got Panganai from Masvingo. With the little resources that they have, they've done an amazing job with non-revenue water reduction. So he's probably got a question for you, and that will be the last question, then we'll close up if you're willing, Ronnie.
Yeah, no problem.
Panganai, go ahead and unmute yourself and you can ask Ronnie a question.
No, it's not a question. I was just clapping for the good buys that you were actually telling us.
Good. All right, good.
Okay, everyone, have a great rest of your day. Stay healthy and stay tuned for the next PAWS event. Again, thank you all for attending. Cheers.
Thanks a lot. Thanks for the opportunity.
Cheers,
Bye-bye, everyone.
Bye.